see some names here that I've worked with in the past. Hopefully everybody can see my screen. Sounds great. So let's get started. What we're here to talk about is network automation. And I just wanted to kind of touch base a little point on what HashiCorp is. And so we build tools really for practitioners, right? And these are used extensively. There's a good chance engineers at your organizations have used Terraform, Vault, Packer, Boundary for your day-to-day tasks of deploying network infrastructure, deploying apps and services itself, right? And they're really the foundation. These are the foundational tools for the most important workloads that we've seen small and large companies use itself. And really what I want you to understand is that HashiCorp itself, we create workflow management tools to accelerate your modern application and your modern data centers. When we transition from this traditional on-prem data centers and environments to more of a dynamic cloud infrastructure, it starts to get complex, right? And we introduce new challenges of security and automation inside the organization. And there are more systems to manage, more endpoints to monitor, more networks to connect, and more people that need access. And this is especially true as organizations adapt this multi-cloud, hybrid cloud environments. These challenges start increasing, right? Security, traditionally in the data center, really requires managing and securing IP-based perimeters. So with networks and firewalls, load balancers, SIMs, and other physical devices have this, restricted access. But those same solutions really are no longer sufficient as organizations move to the cloud or more dynamic workload itself. We need to kind of rethink how we're automating and securing our applications, because this IP-based perimeter or IP as a unit of control is really broken. We got to think of identity as the unit of control when we start automating. The key thing I want to kind of talk to you and present is that we want customers to kind of bridge that gap between apps and networks. We want this consistent delivery, right? Organizations really want networks or want to include the networking part in their app delivery process. When I deploy a new app, or when my team deploys or your team deploys a new app service, some workflow should be triggered because you already understand this workflow. When you build an app that you require load balancing to, you have to go to the load balancing team so they can update the pool members or create the VIP or update the access policy or the address group inside of a Palo Alto. We want to bridge that gap with Consul network infrastructure automation. So for us to get started, really what we've deployed is this Consul Terraform sync. And this Consul Terraform sync kind of helps us achieve a repeatable application lifecycle. So what I mean is we want to automate your workflows. We don't automate tasks on a network device. And that's what some other vendors are trying to do, or they have done with Bash scripts and Python scripts. And they've done a great job, but we want to automate the entire workflow so we can eliminate the deployment of things from days to hours, even from weeks itself. And a lot of customers ask, well, why is it important? Why can't we just use our existing scripts? Why this DevOps method, right? So we want to kind of focus on eliminating these slow manual processes, this increased cost from an operational perspective even, where it takes time and overtime hours to deploy something. And we want to eliminate the risk because the more manual configurations we do across multiple clouds, multiple platforms, multiple devices, the higher risk we can have in outages itself. So let's really talk about our old friend DevOps here, right? And it's kind of DevOps to blame why things in the networking world are failing to automate. And I really don't mean it in a bad way, right? DevOps was fantastic for driving collaboration between development and production teams, between dev and ops. But how do we accelerate the service creation, right? Which could be, a revenue generating itself. DevOps, right, showed us the way to eliminate a lot of risk and to accelerate through this continuous integration testing. But, this continuous deployment wasn't achieved by many itself. And the vision of DevOps was continuous integration in that CI, so in the CI/CD. If you look around, there has been a lot of different definitions. The short version is that if you're not familiar, is that the developers provide an automation testing checks into their code. And these make sure that their code plays nice with everything else that's been checked in it. And if all the tests pass, right, an artifact is provided. And this artifact could be a binary, a container, a framework, something usable, right? And this is the value, the productivity improving and that revenue generating value that comes at the end of it. And that's really called this continuous delivery in that CD of the CI/CD pipeline. But when we talk about continuous delivery, it actually requires much more than this, right? So in continuous delivery is fantastic, right? We have a lot of energy and effort was put into this. I'm sure your organizations have played with Git, Bitbucket, right? All these types of tools that are out there. But we still have manual deployments, right? And why are we stuck in this, right? We still need to update our, F5s or Palo Altos manually. Even if we deploy this app that has a CI/CD pipeline in it. And this is why majority of the operations of networking and security infrastructure is still done through this CLINS GUI, right? It hasn't changed in 20 years, right? DevOps, by automating everything, really is leading up to network infrastructure. And it really put a spotlight on this area and showed us that we really need to change, right? And this showed us that we've been really stuck with a lot of this continuous disappointment. And this is what we call like the third CD in that CI/CD pipeline is continuous disappointment, because we have this whole pipeline built, but someone still has to log into manually to a GUI on a Cisco ACI, an F5, a Palo Alto, whatever that networking device is on-prem or in the cloud. And they still have to manually update this, or they have to kick off a Python script or an Ansible script. It's still a manual task, right? And the network and security industries really respond to this, right? There's been a lot of workarounds, I call it, in automation. Some vendors say that all the network engineering teams need to learn Python, right? So I'm not sure you recall, but I recall maybe like 5 years ago, everybody's learning Python, right? And other scripting tools, because they want to automate this network because this product now is an API. So we need to learn Python and build the script, right? And the problem was that the work was largely developed and explored within silos of a network or a security department. It was never designed in a way to completely or to complement and extend this continuous delivery pipeline. When the networking engineer built a script, he just did it himself. So we still needed that manual handoff from the app team to himself, and then he went and kicked off his script itself. So this continuous delivery would, spit out an artifact, but we still relied on this ticketing-based system where a network or security operator would then receive the ticket and run their scripts. So they would respond a little faster, but it's still a human, right, being bridging these two worlds, still a person running at people's speeds. Depending on how frequent the change is and how long the backlog is, it could really ruin the process. And also being exposed to risk, because when you're doing 20, 30 changes a day, it is very easy just to make one mistake. You copy the wrong IP address, you use the wrong, an older spreadsheet template, right? It doesn't automatically fill. A lot of things can happen, and we can't really blame the operator for this, but we need to focus on tools being used on how to make them better to eliminate and expose that risk and the pressure of the operators under that are under, right? Really, nobody wants anything to happen, right? We don't want outages, but this continuous disappointment has shifted into this gap between two worlds, between continuous delivery and kind of automated deployments itself. And it's kind of fun to blame ITIL for this gap. And a lot of people do this publicly, right? But I disagree. ITIL's intent really was to create accountability and reproducibility, right? Essentially, how can we make sure that something is done the same way each time, and we know everything might go wrong? We look into the same place each time, right? It's really the implementations of ITIL that needs to change, and we can honor the processes, right? We can still create our ticket, right, to deploy this application, but so we are honoring those processes and those ITIL needs, but we can automate those workflows, right? We can do is templatize things. We have repeatable ways where it's not a person repeating the process, but it's technology. And the people that are merely there just to manage the systems, and they don't need to be involved in every single little change. You don't need to always have to change a VLAN, always add a pool member. You can have some type of system itself do that. And of course, this turns out, there's a fantastic technology that bridges these gaps. And that's what we're here for, right? We're here to talk about this network infrastructure automation and how HashiCorp Consul's strategy solves us to get from this automated-ish deployment to a continuous deployment model itself. So Consul Service and Networking Platform really provides a multi-cloud service networking layer to discover and securely connect services. All right, Consul can also dynamically program network devices using Terraform. So we have tons and thousands of different Terraform modules already out there for AWS, Palo Alto, F5, Fortinet, Cisco ACI. What we're doing is we're using Consul to automatically create those workflows and push that configuration to those devices based on the identity or based on what is registered even in Consul itself. Really, we want to have this identity-based workflows itself. And Consul has two elements: a highly available all-active cluster of Consul servers. And this is where the service catalog resides and the state of the applications and services, and applications and services themselves, which run a Consul agent. And this agent constantly monitors the local health and availability of that service. So we have a bunch of web apps, a bunch of databases. We're monitoring that health. Just like if you're familiar with F5 health monitors, the F5 is monitoring the health. We can specifically monitor the health of those applications to ensure that that service is working, right? And it's propagating that information into the entire cluster. So now we have this always up to the millisecond visibility of all our apps and services, where they are, how to get to them, and how to ensure that when anything requests access to these services, we can give them back a reliable, accurate destination for them to get to. So with our Consul CTS, or network infrastructure automation, what we have done is created this lightweight service that resides in your network that takes these tasks, these workflows, and automates your firewall deployment like policy groups. So if I register an application, it'll automatically get deployed into my PAN address group dynamically. If I register an app, in that app, I specify in the metadata that it has VIP, it's part of this load balancer config, it'll automatically be added to the configuration and automatically removed once it's deregistered. So it keeps your networking firewalls, your load balancers really clean in a clean setup. The beauty about Consul is that it doesn't do everything on its own, right? We built Consul to be really extendable and pluggable with many of the popular technologies out there, right? We can use Envoy as a proxy in a service mesh. We can use Consul to integrate popular observatory tools for telemetry and performance alerts. It also works with Vault for certain secrets management and integrates with most network vendors really to achieve that network infrastructure automation. So when we are talking about the challenges that I mentioned, the big thing that I've seen is this ticketing-based system, manual approach, and this error-prone in handling this multiple handoffs between teams. Before joining HashiCorp, I was a consultant doing lots of F5, Palo Alto work itself, and this handoff caused always a lot of issues because I received the IPs from the networking team, then the app team changed their IPs of the apps or changed the port of what service is running to, and it was always difficult for me to ensure I'm getting the right source. So that was always kind of a challenge for me when I was trying to automate something. When we have Consul and we register an app, that means that that app is complete, the service is done. And that application person or the developer has said, hey, this runs on this port, this service, it's in the code, it's registered to Consul. Then it allows Consul itself to send that information to Terraform Sync to be able to provision that device itself. And the way it works, we'll kind of go through it. This is kind of like a high-level architecture where we have our Consul agents talking to, for example, an Nginx proxy or an F5 load balancer or Palo Alto, where as that app gets dynamically added to Consul, it'll be updated dynamically itself. So when we refer back to this network infrastructure, I like to talk about day 0 or day 1 and day 2. There's really 2 parts of network automation, right? Day 0 is realized through infrastructure as code, so Terraform, which solves the challenge of inconsistent environments or states, right? We create a config, a module that all our infrastructure looks this way. So then that's repeatable, right? Easy to establish and easy to provision, have compliance, and it could work across multi-cloud and hybrid environments too. And where it gets more interesting is kind of this day 2 interaction, right? Day 2 network automation focuses on really utilizing the provider ecosystem of that infrastructure as code solution to integrate with service-based networking in order to really establish a dynamic self-service network automation and eliminate the dependency on those manual ticketing-based systems, right? We're kind of allowing operators to oversee the entire workflow, not individually, not for like individual engagements, but in order to implement a series of changes through one singular action, right? So when we take a look at the manual ticketing-based workflow, and I want to just to be clear, I'm not trying to eliminate tickets because we still need that for that ITIL process. But if as an app developer, if I need to scale my workload, right, I have to, one, create a ticket that says, hey, I need a new server to get my workload. But that ticket is then assigned, a new task can be assigned to a network admin. And that network admin says, well, I need an IP address. I need an IP address so I can update the pool members for on an F5 or A10 load balancer. Then I need to update the switch configurations, update the access lists on the firewalls, and I need to make sure that the security team also has their changes and tickets so they can update their firewall policies or they can update their NAT policies itself. So we can automate the workflow entirely from that network admin to that security operations very quickly. And the way Consul Terraform Sync works is we have our Consul deployed. We have Consul Terraform Sync deployed. When an application gets registered to Consul, right, it generates this manifest and initiates a Terraform cloud run, right? and applies the changes to my firewall or my load balancer, right? So Consul comes, Igor, good question. So Consul comes in two formats. You can self-deploy Consul on-prem, on a VM, on Kubernetes, EC2, any cloud service itself, or you can use Consul, HashiCorp Cloud Consul, where it's a service where we deploy and manage Consul for you itself. When we're building Consul Terraform Sync, there's two components, right? The first one is this network driver. And this network driver leverages existing Terraform providers, like I mentioned before, in our ecosystem. You can hit up our website on Terraform providers. You can search for anything that the community has made or the vendor itself has made. And then the second component is these tasks or workflows, I like to call it. And they are really representation of configurations to be applied on the network infrastructure devices based on what's in that service catalog. And these tasks are triggered really based on that service discovery and updates. And I'm going to demo this shortly, right? And leveraging Terraform modules as a source for simplifying this complexity makes this automation really simple, because I can use existing Terraform modules deployed in this example here for Palo Alto, where I don't have to manage it itself. I can let Palo Alto manage it. And all I have to do is update this task that says, hey, I want to change this address group, which you just name address group. I'm going to use the Terraform provider, HashiCorp, DAG NIA, so dynamic address group. And I'm going to apply it to these servers, API and web. And we can get very more granular on how we define these services. And this is where we kind of stitch that gap between the network and the application teams itself. So before I get to this demo, so does anybody have any questions on Consul and NIA? And feel free to unmute yourself and ask if you'd like.
Sebastian, I did see there was a question in the chat. It says, is Consul SaaS?
Yeah, so it is a SaaS service. It's a SaaS service and a service you can deploy and manage yourself. So we have Consul or HashiCorp platform, which runs in our cloud itself, where we manage your Consul infrastructure, or you can deploy Consul on your own network on any runtime. All right, so in that case, let's get to this demo. Here's a visual representation of what I have in my lab. You could set this up anywhere. There's a lot of components in here, but I wanted to really outline, how to manage Palo Alto devices using Terraform and Consul Terraform Sync. So first thing in here, we have Vault. So HashiCorp Vault is a secrets management tool. So in this tool, if I log into it, if you see the GUI itself, it holds all my secrets. So if I go to secret, I have my secrets and my passwords and usernames for my F5 device. I have passwords and usernames for my Palo Alto device. So in my code, I'm actually not putting any passwords. I'm not doing anything. I'm allowing the Consul Terraform Sync to be able to query Vault to get all the information it needs. So then you can rotate passwords, you can change them anytime you want, and you don't have to give them out to people. You can let the system manage that. Then in here, we have on the top, we have a repository. So we're using Git, where I'm storing my code. And this is where we're storing that Palo Alto Terraform module itself. And what I also have, I have it hooked up to Terraform Cloud, right? Terraform Cloud is right here, where I have different workspaces of different environments. So for this lab, we'll focus on this PAN dynamic address group web front. And we'll focus on this F5 front end workspace itself. So I'm storing the entire state of the configuration of that config inside of inside of Terraform Cloud. So I can roll it back anytime. I can see if anything's changed. I have all that auditing and logging in here already deployed. So because in this environment, I'm running it locally in my data center. So I'm running everything off of VMware ESXi. I have a Terraform agent, and this agent communicates with Terraform Cloud. And this agent itself is the one that initiates the Terraform configuration. With that, I also have Consul. So I have Consul configured in my local network. And if we go to Consul, we see Consul in here. It's a pretty basic, straight deployment. We have our 3 Consul servers running in high availability. And currently we have 1 node and the web app is registered. So we have a web app that's already deployed in here. With Consul, we have also our Palo Alto, so our PAN device. We can go to the PAN device here. I can make this bigger. It's a pretty straightforward deployment. For Palo Alto, we have interface for our untrusted zone, a web zone, and a secure zone. So, and in these 2 zones, if I go back to here, we have our applications that are sitting in the front end zone. And then we have our applications that are sitting in the secure zone. Right. So if we go to our Palo Alto, in here, we have our policies that are applied on who can talk to who. And sorry, there's a question here. Hey, Dustin, in the event you need to revert the changes, can you auto save the current config of a switch or F5 and save it onto a Hashi repository? So the way you do it is if you have a new configuration for a switch or an F5, you'd publish that to your repo. So your Git repo or your source of truth. And if it doesn't pass the checks that you have implemented, it will actually tell you to fix it, right? But if you want to roll back, you can always roll back to the previous version of it. So that's already done inside of your Git repo itself. Just as if you would register the app has to actually go through a bunch of checks in its own pipeline that it won't be registered if it fails. And if it does fail, right, the change won't get executed because we're doing a lot of checks ahead of the time to ensure that whatever we're deploying is live and it's working right now. And I'll kind of show it to you in the next F5 demo here. So if we look at our policies, for this example, really what I want to do is have my web apps just talk to my secure zone. Because when I take a look at my F5, I have web talk to secure. They are actually in address group, right? So if I take a look at this address group, right? Oops, let's go to objects here. So this address group is just called CTS, address group, web front. If I go to objects, we have this dynamic address group that was created. And I'll send the link of the code because all of this actually was deployed using Terraform. But I have this web app that was deployed and I have no addresses registered. So I have my config ready. I have no addresses registered. So what I'm going to do is, this is just my VMware environment, pretty straightforward. I have 2 web front servers. I'm going to log into the first one and I'm just going to start this app. All right, right now, if I ping 10.1.2.101, which is the database, I can't ping it because that address is not inside of the address group. So I'm going to start my application. So this kicks off a script that installs Docker, deploys just a basic Docker web app, and registers itself to Consul. And when it registers itself to console, I'll switch to my visual code here, and I'll just make this bigger. When it registers itself to console, here's the script here. Really what I'm doing, and this is the registration process. I'm going to give this up an ID. So this is prod webfront, name prod webfront, production tag. The IP is just a variable. So whatever DHCP gives me adds the IP address in here. It's going to run on port 80. I'm going to have some metadata because this is going to be a web application that is fronted by an F5. So I'm going to say, hey, this F5 belongs to this VIP, runs on this port, is using this template, and here's the domain. Then I'm also going to do a check to make sure that I can ping or do a TCP probe on port 80 of this application. So when this app starts up, I can go to my console server, and now I can see webfront being added in here. So what I'm going to do is I'm just going to actually start the Palo Alto Consul Terraform sync in here. So, and I'm running it manually just to show you how it's done. This is an automated process that would be running in the background. But Consul Terraform sync starts up and it starts communicating with Consul. So I'm going to, let me know if I'm skipping too fast, but what's happening here is the web front, right, node was added. The service production, right, on this IP address and this port was added in here. When I kicked off Consul Terraform sync, it starts communicating with Consul. Oh, sorry, you guys don't see that? Oh, shoot. Let me share. Okay, there we go. This is a lot better. Sorry about that. So I just kicked off Consul Terraform sync. Hopefully you can see my screen now. Perfect.
We see Visual Studio Code right now.
That's right. Yeah. So I just shared my whole thing in here. So what you're seeing is I started Consul Terraform sync. And what I'm doing, it already happened a few seconds ago, Consul ran the update. So it ran Consul Terraform sync ran. It noticed that a new node was added and a new service was started, so web front. So it automatically kicked off Terraform to go ahead and run the configuration. So it did a plan, and this plan said, hey, I noticed that there was a new app or a new service that was registered with the tag web front, and here was the IP address. I want you to use the PAN module to automatically apply it to the PAN. So since that's complete, we can go to our PAN here and click on more. And now we see that that IP address is registered inside of our address group. So we're not configuring anything on the F5, right? We're just applying a task. So now that we have one app on, we could turn on the other one. So if I turn on the other one, and you can see I can't ping anything on this app. So as we turn on this application, hopefully you can see this, and right, I still have Consul Terraform sync is running in the background always. It's constantly communicating with Consul. So let's go in here. So as that app just got registered automatically, Consul Terraform sync said, hey, there's something new was registered. Execute this task. In Consul, we see that we have two new services now under prod webfront. If we go back to our Terraform cloud, we see that there's something running. So we have the state or the config starts running. It says, hey, I'm going to apply these changes. I'm going to go through all my checks that I need to. I'm going to do a Terraform plan. If I'm running this in the cloud, AWS or Azure GCP, I'll understand the cost estimate. Though I'm running this on-prem, I don't have any costs associated to it. Then once it passes the Terraform plan, so the checks, it's going to do Terraform apply and go ahead and configure that firewall to add those addresses group into it. So perfect, added it. Here's the output of it. You can take a look at the states. So every time, as you can see, I ran this a few seconds ago, 3 minutes ago, 3 hours ago, 8 days ago. I can always look at the entire state of the configuration so I could audit this anytime I want at that time, that date. So let's go back to our Palo Alto. There we go. And we click on dynamic groups, and now we have that database or that application is now registered in this address group. And this kind of creates this dynamic workflow. Just as if I were to shut this guy down, I'm just going to reboot this server itself. The app team, hey, we're replacing the server, we're shutting it down. Once again, it's going to, if I go to nodes, it already got deregistered, so there's only Webfront 1 available. The service is gone from that instance. Terraform console has kicked off here. The Terraform cloud is running to make the changes, applying the changes. So if I go to plan, the plan was to destroy. So remove this server out of my configuration. And then it's applying the changes. And once it's applied, if I go back to my Palo Alto, that IP address is gone. Hopefully you found that interesting, because that's kind of neat, where I've let my security team manage the actual policies of here. So we're not taking, we're not taking away the policies from a security perspective from the security team. They let them build the policies that they need to, who gets access to. We're just managing the IP addresses or the tags even of those applications and saying, hey, this is the web group for, or the address group for the web front. Let me manually update it itself. Hopefully you find that pretty neat. Let me know in the chat, or if you guys have any questions on the Palo Alto setup. But if not, we can get over to the next thing. All right, so in the event of console services unavailable, what is the effect of dynamic group? This is a great question, Jordan. I was actually speaking with a colleague last week, because a couple of years ago, they tried to deploy tags with Palo Alto based on DNS. And once they had an outage because DNS failed, so all the tags got removed, then all the objects were gone. So if console is not available, console Terraform sync doesn't get executed, so then no changes are being made on the devices. So if there is an issue with console going down, or there's an issue with console Terraform sync going down, it doesn't affect any changes on the actual device, right?
Got it, thank you.
Yeah. So it is possible to create a chain of tasks in here. And I didn't show it because I wasn't sharing my screen properly, but if we take a look at the PAN configurations to answer your question, here is the config for console, Terraform sync. Here is my Terraform cloud provider. And in this instance, I'm hosting the state in Terraform cloud, right? You can host it locally or anywhere you want. But in here is just a task. And this task, you can add more tasks to this, right? So this task kicks off Webfront. I can add an F5 task to that. I can add an Infoblocks task to it, a Fortinet task, and I can create conditions. So in here, I have a condition that says anything Webfront. I can use registration things that if I have a proper name, where's the little thing? I can go like this. And so anything Webfront after that gets automatically added. We've added a lot of conditions on how you want to deploy these workflows itself, either in a full task or multiple tasks, or single instances that get kicked off. It can be, yes. So right now, there currently is no module to do that. I'm actually going to I'm releasing it next week. But this will create the policies for it. And the module that I'm releasing for Consul NIA and PAN and Fortinet, it will be automatically create policies based on the metadata. So just like we have with F5, and I'll show this shortly, we can have metadata with whatever type of parameters we want. And based on the type of ACL, who's it going to, who's not, we can specify in the metadata for that. So it's going to be super neat to be able to do it. And it's going to be super easy to write because I will quickly show you. I will quickly show you the code. And it's really, this is it. This is the code to be able to do exactly what I just showed you to automate address groups or tags. So yeah, so you can manage some, but not all. So depending on the firewall, so with Palo Alto, the way Palo Alto works is when you start using infrastructure as code to manage it, Palo Alto wants you to manage everything through it, but you can gradually move towards that. Yes, you can, Mohit, yes, you can definitely use Terraform to deploy Cisco, use that XE provider, and you could store all those configuration in a GitHub repo. So the next thing I wanted to demo, and it's kind of close to my heart because I've done a lot of F5 deployments over the last 15 years, and it's using the same infrastructure that I just have, but I'm configuring F5 load balancers in here. And I'm not only configuring load balancing pools, I'm doing the entire deployment. And for us to be successful to deploy the F5s, I have to use AS3 because AS3 on F5 is their extensive app service itself. So if we take a look at our F5, right, I already have one app deployed in here. I have Webfront, my Webfront Terraform sync app is deployed. If I look at Consul and my nodes, this is the app that it's running, app 1. I just called it app 1. It's running the service called web. If I click on this instance, I see there's the IP address that was automatically generated through DHCP. And if I go to my pool members, I see that IP address and service and port. So with the F5 configuration, I also have everything deployed in Terraform Cloud. So I have a workspace in here. And from an F5 perspective, just a side note, I have also to provision these F5s, like this F5 itself, I'm also using Terraform, where I have a Git repo that any change in that Git repo gets automatically applied, and it's triggered automatically in the same process to deploy the entire F5. So the entire code is hosted inside of Git repo. And Mohit, another thing, just a quick note, when you're using Cisco XE Terraform provider, if you scroll all the way to the bottom of that provider on the website, I do believe that there's an import that allows you to import objects that you're trying to automate. So just to let you know. So what we're going to do is we have a bunch of apps in here that we're going to load balance. So I have app 1, it's registered. I have my, if I go here, I'm going to go to my console F5 config, just so I separated them just to make it easier. And I have this task in here where I'm going to load balance anything that has a web tag and anything that has a TCP tag. And based on the metadata in that tag, it's going to define what kind of F5 config it is. So let's just turn on the F5 demo here. So now that I have the F5 console Terraform sync up and running, we can go back to our screen here, right? It's just doing a plan and queue to see what's already registered. I'm going to go to my nodes and I'm going to go to my, close this off, my vCenter, and I'm going to launch my other apps. So I'm going to launch this app 2. And I'm going to launch app 3. So once again, this is just a script that just kicks off. Any app dev people would have their own pipeline to kind of kick this off. So I'm just going to close them down. As these apps start turning on, close this, we can go to our console. And if I refresh, we saw that, okay, server or app 2 server, app 3 servers online. It grabbed an IP address from DHCP. We can see that the web services has 2 instances on it. And we can see that a TCP instance has 1. And the web service is just running HTTP. So when we take a look at this service, we can go to metadata, just like you saw in that code. You can see in here that I'm using an AS3 template called HTTP. Here's my domain name. Here's the virtual server IP. And here's the port it's running to. So console starts kicking off, right? It knows that new services were deployed. Terraform Cloud gets initiated, right? Says, hey, you're doing a bunch of stuff here. There's some states. It did a plan. So the first one was to deploy the whole AS3 config. Here's the server address that it picked. It added the server addresses to the pool. And it applied the changes. So now when I take a look at my F5,
in the meeting now.
when I look at my F5 and I take a look at my front end, it actually deployed the 2 pool servers automatically into it, right? So I'm running this web service with my web configuration on here with my VIP config, and I have these pools automatically done. Because I started 2 services at once, I started the TCP service and the web service. Terraform's kicking off again, as you can see. It did its apply run. And when we take a look at the F5, if I refresh, now we see that I've deployed a TCP app, so just a layer 4, and a web app itself in this product. So I actually built the entire VIP config based on what is in my AS3 template. And I have the pools in here. And it's the same process that I could tie all these tasks together, that if I go into my app 1 and for some reason, right, just do it this way so it's more dramatic, power off this application, right? Right away, console Terraform sync is going to kick in, said, hey, the health is down. Oh no, something happened, right? In the F5 case, the F5 monitor is going to mark that pool member down. So if we go to the pools, right? It's going to mark this pool member down because the health monitor is out. Consul is going to see that that web service is down, right? Not all node checks are failing, right here. Consul is going to kick off the Consul Terraform sync to go ahead and remove those objects, those unused objects from the F5. So we'll just take a quick second here. It's applying, it's in the queue. So it's applying the changes. And then it's done, right? So now that config is clean, my configuration set. So my source of truth is now every single app and service that I've registered in here, right? And the health checks of these nodes or these services is as important to me. So that was the presentation and the demo on this. And the key takeaway is that this Consul CTS for network automation really is going to reduce your best practices to reduce risks. It's going to help you automate pace because it's going to be quicker. And it's really going to get everybody on the same page because the app teams want to register to a service mesh. They are looking at this right now to deploy it. So then you could use that service mesh to be able to automatically automate those sets. So, and just as I'm here, ecosystem partners we're using, that we have on our webpage. And we have a lot of stuff on learn.hashicorp.com. So there's a lot of hands-on labs and services available already. If you hit up learn.hashicorp.console, I'll paste this in the link here in the chat. We have many tutorials from how to build your own 810 F5 console in here. And I can also email everybody if you're interested. I have a full AWS deployment of the exact same demo that you can use to deploy this in your environment. And with that, if anybody has any questions, if they want to go on mute.